Welcome to the second key skill. Now we know what a geometric sequence is and we can identify A and R. We're ready to move on to something a little bit more complicated. I've taken out edXcel's International A-Level exam booklet. This booklet is the booklet that you're allowed to bring into the exam with you, and I'm going to show you where you can find the formulas that are useful to this topic. Inside the booklet, you want to go to the formulas for P2. You see geometric series, so we want to be on page 3. Here in this section are listed the 3 formulas that you're going to need for geometric series. So it's useful to have this with you and to know where those formulas are, and that you don't need to learn them off by heart. We should already know what A is, that's the first term in the sequence, and what R is. R is called the common ratio, so R is for ratio, and that's what we multiply each term by to get to the next term. So here we've been asked to find the nth term. What is the nth term? The nth term is a formula that can give you a shortcut directly to the term that you want. For example, here I've got 2, 14, 98, 686. So each time I am multiplying here by 7. 14 divided by 2 is 7. 98 divided by 7 is 14. 686 divided by 7 is 98. You can check them. Remember, the one in front divided by the one behind should always give you the same number, and that number is the common ratio of R. So all of these times when I put the one in front divided by the one below, I always get 7. So let's just keep a note. R here is 7 and A is 2. Now if I wanted, for example, the 20th term in that sequence, I've been given the first, second, third and fourth terms in sequence. Say in the exam they ask me for the 20th term. It's going to be very time consuming to go all the way along multiplying by 7 so many times if they ask you for a big number like 20 or 50. What we do instead is we use a formula to go directly to that term. So the nth term, we can put in any number for n and generate that term. The formula for the nth term is given to you here. So all we have to do to calculate the nth term is substitute in our A, in this case our A is 2, and multiply it by our R, which is 7, to the power of n minus 1. The reason why this works is if you start here with A, to get this one I've done A times by R. To get this one I've done AR times by another R, so AR times by another R is AR squared. To get this one I've done AR squared times by another R, so now I have AR cubed. So you can see the pattern emerging. So on the second one, I've got R power 1. On the third one, I've got R power 2, and the fourth one, R power 3. So the formula is UN is equal to A, n minus 1, because the power of R is always 1 behind the term number. So here you've got basically R power 0, the first one. The second one is 2 minus 1, R power 1. The third one is 3 minus 1, R power 2, and so on. So this is the nth term. This is the formula that will give me any term that I want in that sequence. If I'm asked, for example, for the 200th term, I will make n equal to 200. We're going to get more into that in key skill 3. For now, we're just going to practice using the formula. Find the nth term here. So I can immediately identify that I have A is equal to 4, R is equal to, well, what do I times 4 by to get to 12? Times by 3. 36 divided by 3, would it be 12? Yeah, or 12 times 3 is 36. And we can keep going like that. So here my A is 4 and my R is 3. So my nth term for question 2, with a equals to 4, r equals to 3, would be un equals a times rn minus 1. Always write your formula first, and then fill your numbers in. 4 times 3 to the power of n minus 1. Be careful that you know that un is not equal to 4 times 3, 12n minus 1. That is a common mistake and it's incorrect. You need to leave them separate. Question 3, we've got 8 minus 16, 32 minus 64. So we've got a is equal to 8 and r is equal to minus 2. Each time here we're multiplying by minus 2. Don't forget we can spot that r is negative because we've got the alternating signs, plus to minus, plus to minus. So here we write down our formula. un is equal to a times r n minus 1. un is equal to 8 times, I'm going to put the r in brackets because it's a negative number, minus 2 to the power of n minus 1. Question 4, we've got a decreasing sequence, so we know that r has to be a fraction. A is the first term, which is going to be 6. Now, to work out my r, 2 divided by 6, and I'm going to cancel that down to be 1 over 3. I can divide both my numerator, my number on the top, and my denominator by 2. And you can check if that works. So for example, 2 over 3 times by r, 1 over 3. That gives me 2 times 1 is 2, and 3 times 3 is 9. That's correct. And 2 over 9 times by 1 over 3. 2 times 1 is 2. 9 times 3 is 27. So here in question 4, my nth term, I will have a is equal to 6, r is equal to 1 over 3, and my nth term will be 6 times by 1 over 3 to the n minus 1. And again, what you do not want to do, what would be incorrect, would be to say 6 times by 1 over 3 would be 2, 2 to the n minus 1. You do not want to do that. Question 5 is probably easier to find the r if you look a little bit further down the sequence. Now, if I go down here, for example, I can see 1 times 10 will be 10. And each time we're moving up by 1 decimal place, so we're going from having 2 zeros in front of the point to having 1 0. So you can see that each time here, I've multiplied by 10. Now, the a in this case is 0.001. It may also be easier for you to write this as 10 to the minus 1, 2, 3. 10 to the minus 3. And I'll explain why to you in a second. Our r in this case is 10. So it's minus 3. This sometimes confuses people because the first space is 10 to the minus 1, the second space is 10 to the minus 2, and the third space is 10 to the minus 3. So to calculate un, I multiply a times r to the n minus 1. A is 10 to the minus 3 times 10 to the n minus 1. Now in this situation, because the base is the same, because they are both 10, you can actually multiply them together. Now if you remember your rules for indices, what you need to do when you multiply two numbers of the same base is add their indices. So you would do minus 3 plus n minus 1. Minus 3 and minus 1 would go together to be minus 4. So the nth term is 10n minus 4. Last one, in a similar example, you can see each one of these are being multiplied together by 9. Again, it might be easier for you to see that 9 times 9 is 81 and 1 times 9 is 9, rather than seeing 1 over 81 times 9 is 1 over 9. Although this will cancel down nicely. So in question 6, we have a is 1 over 81 and r is 9. So to calculate un, I will do a times r to the n minus 1 over 81 times 9 to the n minus 1. These are in different bases, so you can't multiply them. However, those of you that remember from our indices course, 81 is 9 squared. Because it's on the bottom here, you can rewrite that as 9 to the minus 2. Now we have the same base, we can simply add them together. So 9 to the minus 2 plus n minus 1. And the final formula for the nth term is going to be 9 to the n minus 3. So I hope you found that useful. The little trick where if you can write them as the same base, you can cancel them down a little bit more comfortably. The most important thing to learn in this section, now we can find a and r, is to be able to work out how to find the nth term. What is the formula for the nth term? Lots of questions are waiting for you now. Get those done and I'll see you in key skill 3, where we're looking at finding specific terms once we've got the nth term. I hope that was useful. Bye for now.